Implicit differentiation, what is it? So I just want to start back at Maths B, methods, whatever you want to call it, the easy class. Let's differentiate this and we're going to get dy dx, that is the message, 2x plus 3. That is so easy it's not funny, but what's actually happening? Basics of algebra, we are going to differentiate with respect to x both sides. We're going to do it to the whole side. There's a linear rule of calculus or differential calculus, so that when we differentiate all of that, we actually split it up. So the derivative with respect to x of x squared is 2x, and the derivative with respect to 3x is 3. That's all basic. But what's happening over here? How does that get to that? Wouldn't it be nice if there was just a multiply by sign in there, and then we just had that y's on 1, so it goes to the top? Okay, dx of y. Let's multiply that by 1. So we haven't changed anything. We're allowed to do that. And that 1, let's make it dy on dy, because anything divided by itself is 1. Oh, fair enough, okay. And because 2 times 3 and 3 times 2 is the same, let's swap those positions. So I'm just going to put the dy to the front, and that d is going to swap back. That's not equals, that's times of y. Hey, what's the derivative with respect to y? That's like saying, what's d of dx of x? Well, that's just 1. So that is actually dy dx times 1, which is just dy dx. That is what's happening in here to take that y to dy dx. It's clear as mud, I know, okay. We would be desperate to do that in Maths B, and we would put the x's to the other side, which is the same question, you understand. But let's just hold on a little bit. Let's just differentiate. We're going to differentiate with respect to x that side and differentiate with respect to that side. Fundamentals of algebra. We're going to apply the linear rule of algebra, of differential calculus. The derivative with respect to x of x squared is then minus 3. What's the derivative of a constant? 0. And we've got the same thing happening here. So we're going to multiply by dy and dy. We're going to swap those two over. And there's the minus. The derivative with respect to y of y is going to be 1. So all we're left with is, and we can put everything to the other side, plus 3. So we can see we don't really need to get hung up on what the equation looks like. We're just differentiating with respect to x. Okay. So that means when we see this one, we don't need to worry. So we're going to differentiate with respect to the whole side. The whole side, don't need that, okay. We're going to apply the linear rule of differential calculus and go, well, we're going to do that. That's easy. The derivative of a constant is 0. The derivative of x squared with respect to x is just 2x. In here we've got a bit of an issue. We've got to multiply by 1. We're going to swap those two over. We're thinking, what's the derivative of y squared with respect to y? So dx of x squared would be 2x. It stands for reason, and that's going to be 2y. So we've got this dy dx multiplied by 2y equals 0. That's sort of nasty. Let's just rewrite that. 2y dy dx plus 2x equals 0. And we really were challenged to get a gradient function, basically a gradient function. So we want dy dx equals, let's get the 2x to the other side. Let's divide by the 2y. Those 2's will cancel when we get over there. So there you go. That's a gradient function of that original function. Hey, what is that function? You would recognise that as a circle. So let's just... it was 9, wasn't it? So that would be 3 x squared plus y squared equals 9. There's my function. And I was told my gradient function is minus x on y. What's this? Minus x on y. That even makes sense because if I say, let's just go with, let's just pick a point here. I'm going to pick an x value of 3 root 2 on 2. If I just have one x value, how can I find a gradient? Because I don't know whether it's that gradient or whether it's that gradient. I need the actual y value to go into this function to determine which slope I'm looking for. So if I put 3 root 2 on 2 into this value for x, I'm going to get y equals 3 root 2 on 2 as well. And it can either be the plus 3 root 2 on 2 or the minus. So we've got to choose which one we're doing the gradient of. Let's do this point here. Hopefully it makes sense that if I've got 3 root 2 on 2 on the top and 3 root 2 on the bottom, and there's a minus at the front, the slope would be -1. Oh my gosh, that's -1 because I've picked that they're the same distances, so that's that slope of -1 there, which just makes common sense. But I could pick any value for x and then choose the value of y to find out any slope of that circle. That's implicit differentiation. Implicit differentiation is when I've got a function that isn't just y equals, it's got a y squared or other sort of power. Anyway, that's the basics of how it works. We need to do some harder questions and simplify that setting out. So we'll do that in the next video.